मैंने भी ज्वाइन की है।
जी दोबारा बताइए।
सर आप रिपीट कर सकते हैं, आप शायद इंस्ट्रक्शन दे रहे थे।
वही इंस्ट्रक्शन थी एज यूजुअल के 10 पास 4 पे क्विज होगा आपके सामने आएगा स्क्रीन पे इन असाइनमेंट एंड देन यू नीड टू डू इट इन 15 मिनट्स एंड देन द 5 मिनट्स फॉर सबमिशन. So up till 4:30 you need to submit it, right? So those are the uh, general instructions. Okay. So let us discuss yesterday's lecture. So in yesterday's lecture we discussed about the drag and Nusselt number variation for flow over cylinder and sphere. And at the end of the class we discussed about the empirical correlations. The only difference in flow over cylinder or sphere is the definition of Reynolds number, that we use diameter instead of the length of the plate. And then in the Nusselt number definition, then again we have got hd upon k instead of hl upon k. And then in the last class we also discussed about the Nusselt number correlation for different kinds of 2D geometry profiles like circular, square, then hexagonal, pentagonal, flat plate, ellipse. So for those cases, we have got Reynolds number or Nusselt number correlations for different flow conditions. So it is given in the table. So now we are going to do one numerical problem and then we would start the next topic. So first, the statement of the problem, that we have got a 25 centimeter diameter stainless steel ball whose properties are given, density and specific heat, C value is given, is removed from the oven at a uniform temperature of 300 degrees centigrade. Now, initially the temperature or uniform temperature of that spherical ball is 300 degrees centigrade, and then the ball is subjected to the flow of air, which is coming at 1 atmosphere and 25 degrees centigrade with a velocity of 3 meter per second. So the surface temperature of the ball eventually drops to 200 degrees centigrade. So it means that there is a reduction of 100 degrees centigrade due to the flow of air over that ball. So the surface temperature, okay, determine the average convection coefficient heat transfer and during the cooling process and estimate how long the process will take. Okay, so these properties are given. Then the number is equal to 0.7296, K value is given 0.02551. It is for the fluid. So we are talking about the K value for the fluid. It is not K of this stainless steel ball, right? And then kinematic viscosity, which is given. Then mu value is given. This is mu infinity basically, which is at the free steam temperature, and then mu s, that is uh, at the surface temperature of the ball, which is 300 degree in this case. But because it is being cooled down, so we will take it 250, which is the average of 300 plus 200 divided by 2, because this is a transient problem. So now, first of all, we know that we need to characterize the flow, that whether what is the Reynolds number of that. So we can calculate the Reynolds number by V into D divided by nu. Nu is the kinematic viscosity. So diameter of the ball is 25 cm, so it would be 0.25 meter into 3 divided by 1.562 into 10 to the power minus 5. So the Reynolds number comes out to be 48,000, approximately 48,000. So it is still the laminar flow. So because it is a sphere, so we need to use the formula for the sphere, which is only this formula. One formula is given in your book for the sphere case, so we can use this. So which is 2 plus 0.4 Reynolds number square root and the additional terms here. So there is a term of mu infinity divided by mu s. So that is also given in the data. So all we need to do is calculate the Nusselt number from here. So Nusselt number can be calculated from mu infinity and mu s value we have calculated. So Nusselt number comes out to be 135. So once we get the Nusselt number, we then it is just straightforward thing to calculate h by this relation which is given here. Nusselt number is equal to hd upon k. So from here, H is equal to Nusselt number multiplied by thermal conductivity of the fluid divided by the diameter of the that sphere. So if we calculate H value, that comes out to be 13.8 watt per meter square Kelvin. Right. So once we get the average convection coefficient, so the first part has been done. And so it told us that we need to calculate the average convection coefficient for this flow and then estimate how long the process will take. Now, to do the second part, we have got two options. One is that, but even then there would be some kind of complication, but let me tell you those two options. One is by using lumped capacitance method and non-capacitance method. So for
सर एक बात पूछनी थी।
yes, please go ahead.
सर लंप कैपेसिटी मेथड जो होता है वो
जी.
बायोट नंबर जो हमारा है वो 0.1 है कि 1 है जिससे कंपेयर करते हैं।
If I go, okay, this is I think this
सर एक
uh,
कंफ्यूजन थी।
this question is related to today's quiz, but never
जी
mind.
सर।
We can see that slide again. If we go here,
सर असल में
here,
0.1 से लिखा हुआ करना होता है पर 1 से किया हुआ आपने अपनी उसमें
yes,
एग्जांपल में।
where 0.1 से करना होता है, ये 0.1 है. Okay,
सर एग्जांपल खोलेंगे आप।
okay, let me go there. Which one? This one?
जी सर इसी में शायद ये देखिए
तो
1 लिखा हुआ है आपने।
यहाँ पे 1 तो लिखा हुआ है लेकिन much smaller than 1 लिखा है ना, तो it should be actually, to avoid the confusion, it should be biot number less than 0.1. So if the biot number is less than 0.1, only then we can do the lumped capacitance method with acceptable accuracy of the result. Otherwise, no one can stop us from applying that method. But then the calculation of our derived variable would be a little bit inaccurate. ठीक है, आपको समझ आ गई शायद? ओके जी.
जी,
So
बस इसकी वजह से हो सकता था शायद मैं गलती कर रहा हूँ कोई।
my number should be less than 0.1. So thank you for the question. So in this way, it would be clear to all of us. So now, if we go back, we were here. So at this point, right? So I was mentioning, because I was going to mention that first of all we need to calculate Biot number in this case, which would be equal to H Hg upon K of solid, right? Because we are talking about that cylindrical case, so it should be not D, but it should be HLC upon K, and LC would be equal to volume divided by surface area, right? So which comes out to be equal to D by 6 for a sphere. So now, but the problem here that it should be less than 0.1. In the data, if we see, we have not been given the value of K of solid. Instead, we are only given the value of K of fluid. So it means that either you get that value from somewhere for this particular material, or secondly, you can in order to do this, the second method would be that we can calculate, because Q dot is, the units are, if we say units, they are watt. Watt is joule per second, right? So if we can calculate the total amount which has been transferred in this process, that would be in joule. So if we want to get time, total time of that heat transfer, that would be basically it should be equal to, let's see, it should be equal to Q upon Q dot, because in that case the unit would be joule into joule per second. So that would be comes out to be in seconds, right? So now easier way, one way of doing was I told you by odd number. So then if it is less than 0.1, then we need to calculate the value of K of solid, but we can get that value from any table. But because in the exam you maybe you don't have those tables, so for the exam purpose we can use this second method. So now if we want to calculate Q dot, it would be equal to H into AS into TS minus T infinity, right? And for the calculation of Q, we can do M into CP T initial minus T final, because T initial is here, we have got 300 and this is T final 200, right? So this is the way we can do. But what to do here for this TS value? If we want to get this TS value now, because the surface temperature is changing from 300 to 200, it goes down to 200 at the final. This is the value of the surface temperature of that spherical ball. So for the TS, we can take TS average, which is equal to 300 plus 200 divided by, right? So I think I must have done this in this example. I'm not sure. Let's see. Okay, so you can see here. Okay, that is the same thing I have done. First of all, it was AS. So AS is equal to pi d square for the spherical sphere. And then if you see the value of TS, I have put 250. While that, because the initial temperature was 300 and final was 200. So the mean temperature would be 250. So we get that rate of heat transfer per unit width, but it shouldn't be unit width. Maybe it was just it should be rate of heat transfer, and I would correct it. And then in order to determine the time required for the cooling, the total heat transferred I have explained. So we can in order to get to this, Q is equal to mCp delta T. M is basically rho into volume. Rho is given in the data, and volume we know that that is equal to 4/3 pi r क्यूब, या फिर उसको हम उस डायमीटर में भी लिख सकते हैं, ठीक है? So if we do that, it would be pi d cube by 6, or it is 4/3 pi r cube. So this rho value is given, and then we have got pi and 0.235, and it should be kilogram per meter cube. So okay, and then the second thing is the rate of heat transfer, that is the total rate of heat transfer, that is mCp Ti minus Tf. I have just told you 300 minus 200 Cp value is given in the data, m we have just calculated. So now we are going to divide Q total divided by that heat transfer rate. So it would give us the value in seconds. So we can convert it into hours by dividing it with 3600. So it comes out to be 1 hour and 26 minutes. So it means that and the process of cooling this spherical ball from 300 to 200, it would take the almost 1.5 hours, right? So any query in this? So you can do these practice problems as well in the Sanger's book. So we are talking about now the textbook for the convection is Sanger, uh, second edition, which I have shared with you. This is the these are the practice problems you need to do. These are the minimum number of problems you need to do. So I hope that this thing is clear. Now we can start our next topic in the external flow. So up till now we have covered one.
सर
Yes.
सर अगर हम प्रोजेक्ट में जो हीट एक्सचेंजर्स है उनमें इंटरेस्टेड हैं तो उसकी
Yes.
स्टडी हमने अब तक नहीं की तो आप सजेस्ट करेंगे हम वो ऑप्ट करें कि नहीं
कर लें आप, क्योंकि इवेंचुअली तो हमने वो करना है इन द मे बी 2-3 वीक्स टाइम वी वुड गो टुवर्ड्स द हीट एक्सचेंजर डिज़ाइन। लेकिन जो हम स्टडी करेंगे ना वो एनसी सॉफ्टवेयर से उसका बहुत ज़्यादा ताल्लुक नहीं है, थोड़ा सा ताल्लुक है लेकिन बहुत ज़्यादा ताल्लुक नहीं है। ठीक है, तो आप कर सकते हैं। हीट एक्सचेंजर इज द प्रैक्टिकल एप्लीकेशन of this course, so I would always encourage that you do it because we are going there eventually, maybe in 2 to 3 weeks time. Okay,
ओके सर
so up to now we have covered flat flow over flat plate, and then we have covered flow over sphere or cylinder, and now the next topic is flow over tube bank. Now, as Sharif has just asked that whether we should do the project for the heat exchanger. Now, this is first of the practical application of flows over external body. So, uh, one heat exchanger which is very common, that is called shell and tube heat exchanger. Okay. Those type of in that what happens that we have got a shell, and we have here we have got like this. So here uh, one fluid, sorry. So in this, what happens that we have got one fluid coming from this. It is usually the gas one, and then we have got another fluid which is going through the tube inside this shell. Okay, maybe it is not the best descriptions of the tube. So let me draw it again. So basically we have got tubes in this, so we also call it tube bank. And these tube banks you can also see at the back of your fridge. At the back of your fridge, fridge, we have got black tubes, right? So those are also collection of tubes, so we call it tube bank. So what happens that fluid comes here and then it passes through here. So in this we have got two configurations. Either those tubes are, if I draw it in the those tubes. So if these are the tubes, right? So we would have like this. Tube would be something. So the third dimension would be into the board. So the flow comes here. It can be gas. So inside this tube, we have got usually the liquid. Like in the case of fridge, we have got refrigerant passing through these tubes, and the air comes from the outside to take the heat from the condenser tube, right? So in this flow comes here and it passes through this. So this arrangement is called inline arrangement. right? And then we have got another arrangement which is called staggered. What is staggered arrangement? That is something like that we have got this, then we have got this, this. So we have got this. So now we have got one tube here, one tube here, one tube here, one tube here, and then the next row would be again like this, and then the next tube. So now if the flow is coming from here, it has got two paths. From here, if it comes, it would go straight from here to here. Okay? So it has got only one option, that if there is no pressure difference in the vertical direction, it would go in the straight streamline. But for this, because we have got cylinder here, so it would either go this way or this way. So from one case it would diverge, and then again it would come like this. So this is something which we have discussed in a single cylinder case. So for the staggered grid, we have got cylinder in front, so that we can have two paths for the flow. But for the inline arrangement, because they are in one line, so the flow can happen in a straight line, right? So there wouldn't be any hindrance. So now, in order to do this analysis, one way of doing it to do it. Okay, can anyone confirm that you can hear my voice?
सर आवाज आ
Yes,
रही है स्क्रीन
जी
बंद हो
सर।
रही है
sir. आप
Okay,
बताइए.
अच्छा जी. So let me share the lecture screen quickly. So it was just the laptop battery just went away. So I am sharing it. So we were discussing about the let me Microsoft whiteboard. So we were discussing about the different arrangements in tube bank. So mm, now let me complete that so that we can go towards the quiz. So here we were talking about staggered arrangement and inline arrangement. So I have just explained to you. Now we have got three. In order to do the analysis, we have got two options. Either we do analysis on the one tube and then do it on the second tube, third tube, and then, or we can do the analysis on the entire bundle of the tube in one go. So we prefer to do analysis on the entire bundle of the flow. So for that we need to define three things, three dimensions for this. So that let me if I can show you quickly in 2 minutes. So if I draw these three cubes, now we have got if if this is its center line, so there are three types of dimensions involved here. One is the center distance between two adjacent tubes, that is called SL. SL is the longitudinal pitch. And then we have got ST, which is ST is the transverse pitch. And then the other thing is the this thing which is called SD, diagonal pitch. Okay? So these are the three parameters which we define in order to do the analysis. So we will be discussing this in detail in the in the next week's lecture. So I just give you the introduction of the tube bank, that because the tube banks are very much present in all the heat exchanger we encountered in practical application like condenser, evaporators, boilers. So in all of these, because of the limitation of space, we have to have the bends in the tubes so that we can accommodate more surface area of the tube in a limited volume. So that's why we need to do analysis for the flow over the tube. So we are talking about the flow, external flow at the moment, right? So for the internal flow, there would be chapter number 8. So I think I would keep the lecture up to now. So maybe in 2 minutes time, you would see the quiz on your screen. I would remind you again to submit it in time up till 4:30, so that you would be given full credit. Okay? So if you submit it afterward, you would have less credit for that. So I hope that today's lecture is clear. Any queries from today's lecture? Okay, Ji, if there is not, I would give you a break of 1 to 2 minutes, and then you can start the quiz. Okay, thank you. Okay, Ji, have you seen the quiz?
No, sir.
Not yet.
Not yet, sir.
नहीं सर.
आपके पास आ गया क्विज? आपके पास आ गया कोई? असाइनमेंट्स में जाके देखें.
नहीं है
सर
सर.
असाइनमेंट्स में अभी तक
सर नहीं आया।
अच्छा ये क्यों नहीं आया वैसे? मेरे पास तो यहाँ पे शो हो रहा है।
सर नहीं आया।
सर
सर
नहीं
हमारे पास
नहीं
नहीं आया
आया।
अभी तक।
Let me see that. View assignment and
सर चैट में कर दें अगर वहाँ पर आ जाता तो।
चलिए मैं चैट में कर देता हूँ, लेकिन ये आपके पास आना चाहिए ना ये, क्योंकि आपने सबमिट भी तो करना है ना।
सर सबमिट भी करना है तो
वो आना तो चाहिए आपके पास। मेरे पास तो आ चुका है। आपने उसमें जाए
सर आप
अगर
रिमूव करके दोबारा ऐड कर दें।
नहीं, ये रिमूव करके दोबारा ऐड कर दें। 6 जनवरी है आज।
यस सर।
अच्छा 6 जनवरी है। ड्यू डेट 6:30।
ड्यू टाइम 35 कर दें सर।
वो तो कर देते हैं। एक मिनट ठहरे बेटा, मुझे देखने दें कि ये आया क्यों नहीं है। एक मिनट ठहर जाए, सिर्फ एक मिनट दे दें। ओके जी 16 डेट। कैंसिल। ओके जी, मैं अभी ऐसा करता हूँ कि ये मैं शेयर कर देता हूँ यहाँ पे, लेकिन इसकी टाइमिंग कुछ ठीक नहीं हो रही।
सर ईमेल कर देते हैं आपको।
मैं करता हूँ, एक मिनट ठहर जाए।
सर क्विज शो ही नहीं हो रहा कहीं पे।
कोई बात नहीं बेटा, आपको आपको टाइम मिलेगा। डोंट वरी अबाउट दैट। यू वुड गेट द टाइम अकॉर्डिंग टू दैट। so let me let me do this again। ठीक है, ये ठीक नहीं था तो let me create that quiz again, so you would get that now। ठीक है, मैं ये दोबारा आपको क्रिएट कर देता हूँ। आपको अच्छा 2 मिनट देते मुझे, मैं अभी क्रिएट कर देता हूँ नया कोई आपके लिए।
सर आप एलएमएस पे ले रहे हैं या टीम्स पे अपलोड कर रहे हैं?
टीम के ऊपर ही कर रहा हूँ बेटा, 1 मिनट देते हैं। T10 मार्क ट्रांसफर। ठीक है, इंस्ट्रक्शन में अभी कोई नहीं दे रहा, मैं तो ये ऐड कर रहा हूँ। कोई ऐड रिसोर्सेज, सिर्फ 1 मिनट दे दें। कोई उसमें कोई प्रॉब्लम होगी सामने। और कुछ अभी 415 हुए हैं, मैं 420 पे ये कर देता हूँ। एक मिनट है, 420 पे होगा आपके सामने। क्विज आएगा इंशाल्लाह। एक मिनट। ME40।
सर कुछ शो नहीं हुआ अभी तक।
बेटा अभी मैं बना रहा हूँ, आपको शो हो जाता है क्विज, डोंट वरी अबाउट दैट। आपको 420 पे शो हो जाएगा।
एक्सक्यूज मी सर।
जी बेटा।
सर असाइनमेंट मैंने आपने बताया था, मैंने सबमिट कर दी थी, पर सर टर्न इन अभी तक मैंने नहीं किया हुआ सर। सर उसका क्या आपने चेक कर लिया असाइनमेंट?
बेटा मैंने चेक करके उसके मार्क्स भी लगा दिए हैं, अपलोड भी कर दिए हुए हैं। आपको अभी तक पता नहीं चला?
नहीं सर।
CMS पे नंबर चेक कर लें।
सर मेरा आपने चेक किया था?
जी आपके जो असाइनमेंट है वो मैंने चेक करके मार्क्स उसके अपलोड कर दिए हैं।
ओके
तो
सर।
वो आपको वो आपको नजर आ जाएगी, ठीक है?
सर वो
सर टीम
सर
से
बिलाल कह रहा है
10
कोई शो नहीं हो रहा।
बेटा क्विज अभी आपको 420 पे शो होगा, ठीक है? आपको 420 पे क्विज शो हो
ठीक है
जाएगा।
सर, बिलाल कह रहा है ठीक है।
बिलाल कह रहे हैं? अच्छा बिलाल कौन? बिलाल अब्दुल्ला?
नहीं सर, बिलाल अहमद इजाज।
अच्छा अच्छा। बेटा ये बिलाल अब्दुल्ला छोड़ गया है या अभी क्लासेस में है?
सर छोड़ने के चक्करों में।
हाँ क्योंकि वो
सर
अटेंडेंस काफी काफी कम है। अजमत हुसैन यहाँ पे हैं?
सर वो जिंदा है अभी तक सर।
जिंदा तो हैं लेकिन वो HMT के लिए वो काफी कम ही नजर आते हैं, तो मैंने कहा कि एक दफा थोड़ा सा आप उनको बता दें कि अटेंडेंस शॉर्ट हो रही है उनकी, ठीक है?
जी सर।
सर
मैंने
इस्माइल कह रहा है अगले हफ्ते ले लें क्विज।
सर अगर मेरा नाम लिया तो ये हॉस्टल में भी लाइट आई है।
अच्छा चले कोई बात नहीं।
सर हम लोग
कोई
हॉस्टल में होते हैं तो लाइट का इशू, तो अब हमारा अटेंडेंस का इशू चल रहा है, उसका क्या करें?
बेटा उसका तो फिर आप अपने हॉस्टल वालों से करें ना, क्योंकि मैंने तो वही करना है जो मेरे सामने जो प्रेजेंट होंगे वो प्रेजेंट हैं, जो एब्सेंट है वो एब्सेंट है। तो आपके जो है तो मेरे ख्याल से 60 से भी कम है अटेंडेंस। तो यू नीड टू टेल द अथॉरिटीज अबाउट दिस प्रॉब्लम, ठीक है? तो मैंने तो अटेंडेंस उसी हिसाब से लेनी है, जैसे आप प्रेजेंट है तो प्रेजेंट है, ठीक है? आपको एक किसे प्रॉब्लम है ये लाइट का हॉस्टल में?
सर उसामा।
जी उसामा, आपने किसी को बताया है ये?
जी सर इधर वो कभी बताया, इधर हॉस्टल मैनेजर को भी बताया और बेरर को भी।
अच्छा नहीं, बेरर को क्यों है ये? आपको चाहिए अपने UG को को बताएं,
ठीक है सर।
ठीक है? क्योंकि